Oh man, you guys are in for a treat today because we are on the Mynx Beast, bad boy from DN Solutions, and we have a crazy titanium aerospace part, and we're gonna actually go through the entire process. I'm gonna teach you all facets of how to machine this part. And then you can take all of that knowledge, you can go quote SpaceX, Blue Origin, quote the same parts, and you can use these techniques to actually make good money. Boom, let's go. You can hear that end mill sounds so good. So that's the Harvey 3 Aero. I'm taking a 10% step over, full depth, 400 surface square. We're at a chip load of 0.0043. Right now we're just machining the octagon around it. And then we're gonna flip it over and drop it into the octagon pocket on the other vise. Now we stepped up and we're on the second level right there. We're coming around, and as it comes around, it's actually gonna leave an island, and that island is gonna end up being a male thread that's actually sticking up. It'll be pretty cool because I'm gonna actually come down, we use a key cutter to come down around the bottom of it. We're gonna thread mill it. It's gonna come out absolutely beautiful. I'm gonna show you guys all of the techniques surrounding that whole process and legit stuff. Back in the day, I was doing subsea parts and we were making parts for ROVs that went to the bottom of the ocean. And a lot of you guys know the story, but there's a lot of new people that I haven't told the story lately, but we were running so much titanium for all of these parts. You know, they were going to the bottom of the ocean for ROVs that had robotic arms and all that, I just became an expert at machining titanium. Our company just became an expert and stuff. So as soon as I read an article about Elon Musk in Inc. magazine, I think it was like 2007, I was like, I want to do parts for that guy. And I started like sending letters, I started like sending emails, I made friends with the ladies in the office. I did everything to get through that door. It took me 6 months of non-stop trying. And then I got an opportunity, and in one single day, I came in, I looked at my email, I had quote after quote after quote. They just got tired of hearing from me, and they're like, okay, let's see what this guy can do. Yeah, we started quoting, and then we started running parts. And that made us the first vendor for SpaceX outside of Hawthorne, outside of that area. We were in Northern California, and it's crazy. So, you know, it's just like a testimony. If you put your mind to something, you can achieve great things. I made mistakes when I was young. I got in trouble for street fighting and ended up going to prison for hitting somebody with one punch. And I come out of prison, I have no opportunities, I have no money, I have no college, no nothing. Didn't even do good in school. And all of a sudden I'm making parts that go onto rockets that go to space. It's the craziest thing. Now we teach the world how to do it. All the secrets, everything that we learned how, we just teach you guys how to do it. Love it. It's my passion. Boom. Oh man, we got titanium chips. You know what's even better than that? We're about to have a Boombastic open house on May 2nd and May 3rd. Over 1,000 people are gonna come through here. We're gonna have machine demos, crazy technology. We're gonna be teaching you guys some crazy skills, cutting titanium, inking out stainless, all of it. EDMs, Swiss machining, regular machining, Hellers, DN, all of it, Siles, everything. We got a chef, we got crazy food, big open house, register for free. We're gonna feed you for free. So register right down in the description, hit that link, register to come to Titans of CNC, the biggest open house, only open house we've ever done. Boom. And this is basically the operation we're on now. The way that you actually look at this print is, you look at the print, you have a section cutaway, so you basically take from the A to the A, you take it away, and then you look at it from the inside, and that's that view right there. And then we can see there's another section that's actually cut away from there. So if we go to the next page, we'll come to that section right here, detail A. And then when you look at this, you'll see 2 times we have a 3/4 16 UNJF 3A. So that's a male thread that's sticking out there. We got a relief coming in here, which we'll hit with a key cutter. And we got some nice tight tolerances as far as the 0.419 diameter coming through. We got true positioning, and it's plus or minus 1/1000th. When you look at this print from our Aerospace Academy, this is a legit print. All the notes are completely legit, and the specs are exactly like you would see if you're making this part for SpaceX, Blue Origin, Lockheed, any of those companies. I'm gonna actually pop this whole program right here up on the Aerospace Academy so you guys can see everything. You can see the speeds and feeds. If I put it on the Aerospace Academy, we'll be able to attach all the documentation, so you can actually grab the prints, you can grab the setup sheets, you can look at the entire process, you can look at the video, and that's at aerospaceacademy.com. Boom. We got coolant through so that at the point that the insert's hitting the material, the coolant is right there to cool everything off, so we can actually make some nice chips, get right through that material. Super good. The Mynx Beast, baby, from DN Solutions. Love this machine. So you can just see the drill. Listen to that. It sounds so good. It's just going straight down inside, popping out nice big chips. Beautiful. So we just broke through. Boom. I'm gonna stop it right there. Woo! The drilling went absolutely perfect. Oh man. Now that we actually have machined everything around and on top, now we're gonna actually drop to a 1/2 inch Harvey 1 TE. We're gonna drop into the hole. We're gonna start pocketing with the 1/2 inch. Then there'll be some other cavities that have smaller radiuses on the outside. And then we'll drop to a 3/8 Harvey 1 TE, get all those radiuses. I like this cutter when I'm down inside pockets, and actually I take a nice cut, boom, boom, boom. We got the Synergy 735 coolant blasting on it. You listen to the sound of that cut right there. Just move. That's cutting titanium, 604V. Sounds so good, amazing. Now, it might seem like I'm going slow, but if you actually look in a machinist's handbook, a standard surface foot for titanium with carbide would be at about 175 surface foot. So 400, I've more than doubled that, but it's the technique. Going all the way down, taking a smaller radial, but a bigger axial, so you get the total MRR, and it sounds so good. And when you do that, you actually get more rigidity in that cut also. So I was running flood coolant and through the spindle coolant, and that's why it was just like raw. But most of the hard cutting is done now, and we're just coming in and kind of shaping the pocket. So I went ahead and turned off the through the spindle coolant, left just the flood, and get a little bit of a view. The whole thing with the TE is that because of the geometry of the tool, it can actually ramp down at 45 degrees. So I didn't actually program it at 45, I programmed it at like 10, but like helical in, boom, and it's just doing this blind pocket, and sounds beautiful. We're in a tight little pocket down here, so I'm still going at 10% step over, but I dropped the surface foot down to 300, and then it's going into the ramp right now. You can hear it like ramping down. No pre-drilling, just ramping straight into the material. There you go. Also drop the surface foot when I do the ramp. Basically cut that down, ramp inside, speed it up, boom. Chip load also came down, is at 0.003 inches per tube. Check it out. Now you can see we came around the outside, we stepped up on level, came around, then we stepped up one more level, and we left a little island up there. That's gonna be the male thread, 3/4 16. And then you have like multiple levels of pockets inside. And then basically the radiuses get nice and tight over here. So I went from like a 3/4 inch Harvey 3 down to a 1/2 inch Harvey 1 TE down to a 3/8 TE. Nice intricate work, boom. Next thing we're gonna do is we're gonna actually come through with a 0.257 diameter drill. We're gonna drill around the outside, and we're gonna come in with another drill. We're gonna drill right through this bad boy right here. Then we're gonna open up the counter bores, and then we're gonna do some more finishing. Let's go. We're at 3.92. Speed on the spindle is 1635. To get that, our surface foot is about, I think it was like 110, 109 on the surface foot. And then we're at 0.0024 on inches per rev. Kissing the top of the spud that's sticking up. It's going to end up being a male thread. So I had the rougher come down. Then I actually brought in my finisher, my 3/4 inch finisher, Harvey 3 Aero, and I kissed on the top, and now I drop down and I'm actually finishing the outside. So now we're under the 3/8 Harvey 1 TE finisher. So this tool's gonna come in, it's gonna clean up the pockets, make them absolutely beautiful, and then we'll come back and we'll drill right through the top. Come over here, there's a lot of coolant in there, but you can actually just see it right here. This is the absolute, so this is how deep it's going right now. See the Q8 right there, Q8? That's my PEC right there. So even though it's a through spindle coolant drill, I just like to get some coolant in there, some extra coolant, get the chips out of it and stuff. So now we have a 1/4 inch Harvey 1 TE. We're actually doing all the counter bores right there. I got a surface foot of 200, and then my chip load is at 0.002. right, now we're getting intricate. So we got a 1/8" Harvey 1 TE. This is actually gonna drop in and it's just gonna ramp slowly all the way down and basically do an O-ring groove at the bottom of the cavity or pocket. Then I'll have a finisher that's gonna come in and just come in and kiss it, boom. So we have no witness marks. There's no lines. The O-ring has to be absolutely perfect. I like to just do like a nice ramp from above the surface and then just ramp slowly down in, getting to the bottom, and then I just come around, boom, and I just ramp out, come up. So as you come around, you can actually look at the absolute, and you can see as we're moving in X and Y, we're also moving down in Z at the same time. Now it's chamfer time. So now we're actually chamfering it. So basically all the O-rings, all the, the diameter in the middle, all the pockets, the outside, we're just putting a nice chamfer around everything per the print, making it absolutely beautiful, taking all the sharp edges away. And after this, it's gonna look really good. Now, one thing to think about when you're using a chamfer mill is I have different depths and different widths. So when it comes to an O-ring, basically it's very shallow. So I'm gonna actually program it in a way where I only use the tip of the chamfer, like just make it very small. So if it's like, 125 thousandths wide, for instance, I'll probably go off like 40 thousandths from one side and then drop down a little bit, So I'll just use a little bit of the tip. But then if I'm doing a bigger chamfer and I have all the room in the world, then I'll use a bigger part of the chamfer tool towards the top, and there'll be more strength there. And then I'll program it and I might be like 150 off, 150 down, and then use a different part of the tool. So depending on where I am in the part, I'll actually program it differently based on the depths and the widths that I'm dealing with, using different parts of the chamfer tool, which helps with the chamfer tool also and the longevity of tool life, because you're using different parts of the edge to actually chamfer the part. If you only use one specific part for the entire thing, then you're gonna be wearing on that exact place right there. So, little words of wisdom. Now I'm chamfering the top of the boss where the thread is gonna be. So I went on the internal and then I'm going around the outside. Then I'm gonna come in with a key cutter, a special key cutter that we actually made on the Walter grinders. Chris made it. It's gonna come down, actually cut around the base of it, and then we'll be ready to thread mill. So you can't see anything right here, but we're actually thread milling the 5/16 18. And this thread mill has teeth coming all the way down. So what we do is we basically drop to the bottom and you basically just heel pull up, boom. I like to just come out, come back in, and then just do it one more time, boom, do it one more time. That allows chips to flush out. And yeah, we're just going all the way around, nice and easy. I used to try to tap some hard materials and different things, but when you get into aerospace jobs and the material itself is like $3,000 for a piece of material, I just went straight to thread milling pretty much everything, because if you actually break a thread mill, you can just take the thread mill out, you can replace it, you can pick up your thread. If you're tapping and you break a tap in there, like it's a nightmare. So. All right, so now we're going to a key cutter. This is a special key cutter that Chris actually made on the Walter grinder. So it comes up underneath the thread, but then on the top, it has the perfect angle for the thread. All right, so it's gonna actually undercut the thread, and it's gonna give you the perfect chamfer basically on the thread for the lead in and lead in, lead out, all that. Another thing too, when I actually come in with like a key cutter, like you're dealing with tense. Like I'll think about the pressure of the tool, but I'll never like, if you have like a bottom surface and I finish at say, you know, half an inch down. If I actually come in with the key cutter, I'm gonna actually come down, but I'll be, instead of being like a half an inch, I'll be like 0.4996, maybe just like 0.4 above it, just so I don't scrape the bottom and keep it nice and clean. And then I'll just make simple adjustments so you can't feel anything, just so it's like beautiful. Last tool. This is the last tool right here. 3/4 16 thread mill. And then this op is complete. Man, the part looks absolutely stunning. We're gonna put it in inspection. We're gonna double check everything right before I take it out. I'm gonna actually double check the threads. You can always comp the threads if needed, but I'm pretty sure that I got it absolutely perfect. Been doing this for a long time, so let's see. So right here we have a 5/16 18 UNJC3B. So I'm gonna pop this guy in here. Ooh, nice, nice. Look at that. Super nice. Drops down. Now we have the no-go. And it does not go. So you can see the turn right here. It won't go. I turn it, just like quarter turn, and it comes out. So basically it goes quarter turn, absolutely perfect. Now we got ring gauges to actually check out the 3/4 16. So we got the go gauge right here. So this is a 3/4 16 UNJF3A, nice and fine. So I'm gonna pop this guy on. We're gonna make sure it goes on absolutely perfect. Ooh. Love it. Look at this. Oh, just beautiful, beautiful thread. Wow. Love that. A lot of times when you do thread milling, you end up knowing how much you go just a little bit more. Because from experience, you keep having to comp, 3/1000ths or something, So it's just over time, you end up getting it absolutely perfect, But that's the go. And this is the no-go. So I'll pop this guy on. Ooh, stops right there. So you see it stopped. It's not going. So I'll rotate it. You can see right here, I'll rotate it. And it's already lifting. So that's like quarter turn, basically quarter turn, and it's coming off. Absolutely beautiful. Beautiful, baby. Boom. So I got my boy Travis. Travis, come over here, son. What's up, brother?
Hey, how you doing, man?
Cool. I checked the threads, the internal threads, the ID and the OD. Everything looks beautiful, so I'll give this to you and you can put it on the CMM and get it checked out.
Sounds good, man. 100%.
All right,
Gotcha.
and then we'll do the second op.
Awesome, man.
Boom.
Love it.
A few moments later.
And you know what is awesome is I was just talking to you about Travis over there, and boom, he's already working on the part. What's up, brother? And we got the part right here on the Mitch Toyo Krista Apex. You're gonna check out the part.
Yes, sir.
Make sure everything's beautiful. Then we're gonna flip this thing over, put it back in the machine, do the second op. It's coming in a future video. Boom. Thanks, brother.